Hi guys, it's Mr. Turberville here. Hanging out at the beach and make me some Mountain Dew here. Mm. Well, wish I was, but that's okay. What we're going to do in this video though is we're going to take a short trip through solving absolute value inequalities. So it's going to be real similar to the section 2 with equalities. Just going to have to do some shading a little bit. And get you a little saying with less than and greater or, and that'll take care of a whole lot of it. So let's get right after it there here. Let's go to the next slide. So in section 3, solving absolute value inequalities, they give us this example here of absolute value of x plus 2 is less than 5. And one thing you could do is just set up a chart and do the whole thing. Now me, being lazy but smart lazy, I just subtracted 2 on both sides instead of having to do it over and over and over again. I just subtracted it once, and now I can just simply put check marks in there. Is it work or not? So is negative 5, is the absolute value negative 5 less than 3? Well, absolute value negative 5 is positive 5, so that's a no. Okay, is absolute value negative 4 less than 3? No. Is the absolute value of negative 3 less than 3? Absolute value negative 3 is 3. That'd be equal, but this doesn't have an equal to sign, so that's a no. Okay, how about negative 2? Is absolute value negative 2 less than 3? Yes. Yes. Negative 1? Yes. 0? Yes. 1? Yes. 2? Yes. 3? No. 4? No. 5? No. So how's that kind of look like on a number line? So what we're going to do on a number line is we're going to put an open dot on 3, an open dot on negative 3. Isn't that where the spots came in, right? Okay. Now, and where did all of the yeses come from? Where did the yeses come from? In between those two. In between those. Because remember, we said absolute value. You got the both sides. Write it once like it is. Write it again. Throw a negative on it. But with the inequality symbol, if you were going to write this twice, okay, you would end up writing it one time with the less than symbol. And then when you put the negative on, wouldn't that make it flip the arrow too? So what would that look like? Well, it would look like this. It'd be like x is less than 3, x is greater than negative 3. Now, I should say something in there, right, as well. Now, where'd all these things go? So we're going to shade in the middle here. Get back over here to this shading. So we're saying that all of this stuff in here would be a solution. So as long as it's bigger than negative 3 and smaller than positive 3. So you understand why I said and? Because if I said just bigger than negative 3, that'd come all the way up, right? But I'm just looking for things that are between those two. So that's an and statement, okay? And what we're going to end up finding out real quickly here is that less than, a less than symbol is an and statement, okay? A greater than is an or statement. So if it had been a greater than symbol, we would have shaded on the left and right hand sides. Okay, because we've been looking for things smaller than this. And now let's just double check. Did I say things smaller than 3? Is that thing smaller than 3? Sure. And things bigger than negative 3. So everything's checking out, no matter how you look at it. So the first couple of questions in the assignment, okay, let's get back over here to 1. They just got you an equation that you got to scroll up to see. There it is. And all these numbers, and they're basically saying which ones are solutions, which ones are not. Basically, which of these numbers can I plug into this equation that would give me a true statement? Because that's what a solution is. That which you can plug in and make it true. Okay. And so that's kind of where they're starting off with the assignment. And I thought I'd go there. Now, that's algebra way and plugging it in. And hopefully this is something of a review for you, is that but hopefully maybe or maybe not, you remember this. When you get a less than symbol with absolute value, you're going to end up with an and. Okay. And so ands are always going to look like, whoops, it's wrong color. Let's stay with red. Ands are always going to look kind of like this. Okay. What's an or going to look like? Well, an or generally is going to look like this. Now, it has nothing to do with whether they're open dots or closed dots, okay? Now, and there are a couple exceptions to this where they completely overlap, but they're very, very rare, okay? And just one other refresher. Could the absolute value ever be equal to a negative? So it's not going to start off negative here. We had to do what? We had to flip the arrow and drop the absolute values and bring a negative in to even get that to happen. So watch out for those two. So that's cool, but I don't want to do all that. I don't want to do all that, which is So what I'm gonna do is I'm gonna either use this guy, the original, or this one here. But I'm gonna go back to the original. Okay. So the original was absolute value of x plus 2. So here's the original function there, and on the left hand side. And then what would 5 be? So let me put 5 in here. It'll be right about here, I think. And look at what happens here. Where do they cross? Where do they cross? They cross right here and right here, don't they? What numbers are those? Well, that's -3 and that's +3. Huh, isn't that interesting? So what you could do is just stick with this guy right here, graph it just like we did with the equalities, figure out -3 and +3, and now you only got to do one thing. Is it going to be shaded in the middle or shaded on the outsides? Well, since it's a less than, it's an and. So I would shade it right there. So instead of just drawing a number line, let's just take this regular graph here, and then we can say, hey, that's going to be greater than -3 and less than +3. Easy enough. Okay, another couple quick ones here. This guy here, we got 4 minus x. That's kind of a weird way to write it. But again, they're talking about this same thing up here. But we're going to subtract 15 over. That makes it easy to work with. Had to do a whole lot of zooming out to get to 21. We could do that. And lo and behold, they have a greater than, and they use the word or. Okay, so I'm going to write that again. Okay, so we got greater is an or. Say greater, and then less than is an and. Okay, less than is an and that is what these things right here are saying right there. That's what they're talking about. And so greater than is an or. You see how that worked out. They just wrote it twice, and one time. And it's interesting in the book. It's weird. Not completely weird, because they like to do the negative because that lands on the left hand side. I get that, but so they wrote it just like it started, without the absolute value bars. That's important. And then they wrote it again, but this time they flipped the arrow and put their negative sign. Solved it, and we see that x is bigger than 10 or x is smaller than -2 is how that would work. Okay, and you know that sometimes in life it's fine. You go like, hey, come on over. As long as you're here between 3 and 6, we're good. Good. 3 and 6. Now, don't come before 3. Don't come after 6, but you can come over and hang out with me, right? Or it could be that says, hey, I got to run an errand between 3 and 6. So you can come over and hang out at the house with me as long as you get there before 3. Okay. Or if you can't get there before 3, you can come after 6. I just can't, I won't be home during that time. You can come hang out with me. See, that's just normal stuff. Okay. That's how life works sometimes. And so these are equations that kind of go with that concept. All right, well, here's a less than or equal to. So they added 10 to both sides. So what's that going to land me with here in this box? Well, that's going to be 8, right? Is that 8? Yeah, and then so we're going to have it, or they switch the sign. So we're going to put -8 here. And they also, let me go ahead and highlight that. See, they switch the sign here. Watch that. But then, whoops, down here. And then what did they do over here? They left the sign and brought their positive 8. So the right-hand side is just like up here. The left-hand side, they switched and also put the negative in. So subtract 4 on both sides, and that's going to give me negative 12. And subtract 4 over here gives me positive 4. Okay, so the solution is x is greater than or equal to negative 12 and x is smaller than 4. Okay, so it's going to be between. And how you could write that as an inequality, you're going to write the negative 12 first, and then the 4 over here, and then you could graph it, and these got equal to, so you would put nice, ooh, that's ugly. Come on, here you go. Try that again. Nice closed dot negative 12, nice closed dot at 4, and then you would shade in between. So that's how we would do it algebraically. Let's go over here and grab our calculators, or how would we do that on the calculator? Okay, so we got 4 minus x plus 15, and that right there is going to end up giving us this red graph, okay? And then, oh, excuse me, I apologize. It's 4 minus x, the absolute value, gives us this red absolute value, and then the 6, right? Now, this is a great OR, so this is an OR statement, and it means an open. So what I'm going to do here to demonstrate the solution is I'm going to put an open dot here and an open dot here. And it's great OR, so it's an OR. So shade out here and shade out here. Doesn't that look a lot like the just regular number line? Okay, and so we drop that down. That's negative 2. Come down here, and that's a 10. Okay, negative 2. This thing just doesn't want to show sometimes. And then that's the same idea, is that right there. And so you would say this is um, x is less than negative 2, or x is greater than, bigger than 10. Just having a hard time sometimes here. There we go. And so that's how that would look like. And you could kind of skip through all of those things, except maybe this first one. And you could do that, but the only problem here is that you'd have to zoom out to get that 21 in, because our standard window only goes from 10 to 10. You can do that, but if you can take just a quick step and make it simpler, I'd do that. And so like same thing here. And so here is our x plus 4, which means it shifted left 4. And now it's going to have an 8 go with it. So let me put the blue here on the 8. Kind of harder to see where they cross here, but you can I bet you can guess if this is negative 10, that would be what? Negative 12, right? And these are closed dots. And there's your 4. And since it's a less than, that's an and statement. Easy enough. So very, very similar. Now, I do want to just to do a refresher course on how this looks on the calculator. Okay, going through the steps. So what's this? X plus 4 less than or equal to 8. Okay, we'll do that one. So let's clear this guy. Get me out of the way over here. Okay, and oops, I gotta go up. Okay, it's not a touch screen. All right, clear him out. Come back up here. Oh, a little too much. Sometimes this thing just don't want, well, we'll do that one, okay? And we said that that one was going to be 8, right? 8. Okay, let's see if it'll let me go back up to, there we go. And this other one was going to be alpha y equals number 1, absolute value, x plus 4, I believe is what it said, x plus 4. There we go. Then hit a zoom 6. Okay, whoops. Okay, it's a good opportunity. So this guy is hanging out over here. So how can I change my window? Well, I can zoom, but watch out. I can also hit window, and it says it's currently going from negative 10 to positive 10 on the Y. What if I change, come down here, and I make that, come on, instead of negative 10, let's make it negative 15. And then we'll pop down here and we'll just go to, I don't know, 7 down there. And now instead of hitting zoom 6, I'm going to hit graph because zoom 6 would reset it, right? Well, good grief. What was I thinking? I was doing the Y's, wasn't I? What I should have been doing was the X's. Well, okay, so what I'm going to do is I'm going to hit zoom 6 to reset it, go back to my window, and now go negative 15 on my X values. And that'll happen sometimes to you guys. Don't freak out. Just go change the other one. Go like, I knew I was supposed to be doing the other one. Just go fix it. It's okay. There we go. That's better. Now I'm going to hit, I want to calculate these intersecting points. So I'm going to hit second, calc, number 5 for intersect. Okay, and for the first one, we're just going to hit enter, second curve, enter, guess. Yes, we do. And it shows that that one was the closest one. All right, that's fine. So there's our x equals 4. Okay, so let's do it again. Second, calc, intersect. Now, before we go anywhere else, we're going to have to do what? Bring that little x over to the other side. I just got to get it closer to the other intersection because it's going to automatically go to whatever is closest to it. So we just hit the enter, 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 and bam, there's the negative 12. Okay, so I didn't do a whole lot with the calculator on this video because I did on the previous one. That's all you have to do. It's the same thing. The only difference with inequalities, instead of just being negative 12 and 4, it's either going to be shaded to the left and right or shaded in the middle. Greater or is going to be in the middle because that's an and. Okay, less than isn't. Oh, greater or is or. Apologies, getting it backwards, aren't I? Greater or is or, means less than or greater than. If it's and, it's going to be shaded in the middle. So those would be the solutions for those inequalities. Much the same as the previous one, real short assignment. Hope it helps. Let me know if you have any questions.